First that we need to do is we solve the chemical formula of type 1 binary compounds. But in order for us to successfully solve for the chemical formulas, we need to do as follows. Let's say, for example, we have cesium phosphide. The very first thing that we need to do is to break down the cesium phosphide into elements. Now, we have Cs for the cesium and P for the phosphorus. The Cs has 1 charge and the P has 3 charge. The Cs and P were derived from the periodic table. The next thing we do is we balance the charges. But how do we balance the charges? Since this is a type 1 binary compound example, we need to do the crisscross method. But what is this crisscross method? Given this example, crisscross method should look like this. The 1 charge from cesium will be put into here, and the 3 charge from phosphorus will be put into here. And that will give us the chemical formula CS3P1. Since P already stands for a phosphorus, 1 is not necessary. And the final chemical formula for the cesium phosphide is CS3P. Now we do the vice versa. This time, we name type 1 binary compounds. But in order for us to name type 1 binary compounds, we need to do as follows. Let's have an example. We have a chemical formula CS3P. The next thing we need to do is to identify the cation and the anion. In this case, cation is the Cs and the anion is P. In the process of naming type 1 binary compounds, the name of cation remains as the name of the element. In this case, Cs remains its name as cesium. Next is that we name the anion. The P for anion stands for phosphorus. There is a process on how to properly name an anion. In naming the anion of a compound, we need to get the element's root and plus IDE. In this case, the element's root of phosphorus is phos. Now we know the element's root of phosphorus. All we need to do is to add IDE. Now that we properly named the anion, we must combine all the names together. In this case, we get the name of the cation and combine it to the anion. And lastly, we have the compound name cesium phosphide.
Writing a chemical formula for type 2 binary compound. First, let us have an example. Tin 2-phosphide. The chemical symbol of tin is Sn. The oxidation state is 2 as given by the Roman numeral. Phosphide is derived from phosphorus whose symbol is P. Its oxidation state is -3. It should look like this. So far we have Sn2P -3. Next is we need to balance the charges. To balance the charges, we must find their least common multiple. The least common multiple of 2 and -3 is 6. Divide each element oxidation state or charge to the LCM. Two divided by 6 is 3. for phosphorus or phosphide, negative 3 divided by negative 6 is 2. We need 3 atoms of tin and 2 atoms of phosphorus or phosphide in order to balance the charges. It should look like this: Sn3P2, and that will be our final answer. Now let us name chemical formula of type 2 binary compound. First, let us have an example. Sn3P2. Sn is the chemical symbol for tin. Tin is not in the first or second column, therefore a Roman numeral is needed in the name. We'll come back to that shortly. P is the chemical symbol for phosphorus, whose root is phos. Add the IDE to the ending to have phosphide. At this point, we have tin blank phosphide. To find Roman numeral, find the charge of the anion. The anion of this example is phosphide, and the cation is tin. P has a negative 3 charge. Multiply times the number of those atoms to get the total negative charge. There are 2 atoms of phosphide or phosphorus. Therefore, negative 3 times 2, and we'll get negative 6 balanced total negative charge with total positive charge. The total negative charge of negative 6 must be balanced with total positive charge of positive 6. Divide the total positive charge by the number of atoms to get Roman numeral. There are 3 tin here. Therefore, we will have positive 6 divided by 3. We have 2. The Roman numeral is 2. Put the piece together to get the name tin 2 phosphide, and that will be our final answer. Now let us write formula for type 3 binary compound. Our example is disulfur monoxide. First, identify the element present in the given. Here we have sulfur and oxide or oxygen. Next, here is a prefixes table. We will use that later. Take the element symbol of each element. Sulfur is S, and it has di prefix attached on it. Here, in the prefix table, di is equivalent to 2. So, we will write that as S2. Here we have oxide, and we can see that it has prefix mono attached on it. In the prefix table, mono is equivalent to 1. So we will write that as O1. It should look like this: S2O1. Since 1 is not necessary, we do not need to use or put it in the element. And our final answer will be S2O. Now let us name a chemical formula of type 3 binary compound. Here we have S2O. Our first step will be finding the element present in the given. S is the element name of sulfur, and O is the element name of oxygen. Take the root name of the oxygen. The oxygen root name is ox, and add IDE for us to have oxide. As of now, we have sulfur oxide. Here we have our prefixes table. As you can see, there are 2 atoms of sulfur present and 1 atom of oxide present. We will write the prefix first before the element. Here, 2, as you can see, di is the equivalent prefix in it. So we will use di, then add this sulfur. We will have disulfur. Here we have 1 or mono, and add oxide, we will have monoxide, and it should look like this: di sulfur mono oxide or monoxide, and that will be our final answer: disulfur monoxide.
Next is we solve for the chemical formula of compounds with polyatomic ions. Let's say, for example, we have barium perchlorate. The next thing we do is we separate the barium perchlorate. First, we have the barium, and next, we have the perchlorate. But how do we get the perchlorate? Perchlorate is given in the list of compounds with polyatomic ions. These polyatomic ions are always given by the teacher or instructor. The next thing we do is we balance the charges. In balancing the charges, the process should look like this. The positive 2 charge will be put into here, and the negative 1 charge will be put into here. In the case of barium, 1 is not necessary, since barium is already 1. And in the case of perchlorate, ClO4 is separated from 2 because we need to separate the natural charge and the charge that we supplied. That's why we put parentheses. And finally, we have the chemical formula BaClO4 2. The next thing we do is we name polyatomic compounds. In order to name polyatomic compounds, we need to do as follows. Let's say we have the example BaClO4 2. First, we name the Ba, and it is barium in the periodic table. Next is we name ClO4, and based on the examples, ClO4 is perchlorate. That gives us the final name, barium perchlorate.
How to get the formula of hydrochloric acid? First, we need to identify the elements and the symbols used. One is hydro. Hydro is the prefix of hydrogen, and the symbol of hydrogen is letter H. Next is fluor, the stem of fluorine. The symbol of fluorine is letter F. After we know the symbols, we need to balance their charges. Hydrogen has 1 positive charge, while fluorine has 1 negative charge. 1 minus 1 is equals to 0. So that means they are balanced. And now, the formula will be HF. How to find the name of the formula HF? First, we need to identify the elements of each symbol.
H is hydrogen, and F is fluorine. We need to take the prefix of hydrogen, which is hydro. And now get the stem of fluorine, and it is fluor. Since fluorine is an ion, that means the suffix would be ic or ic. Now we need to combine these three. So hydro plus fluor plus ic is equals to hydrofluoric. So the name would be hydrofluoric acid. How to name an acid? We need to remember this pattern to name an acid easily. The first line is, my ride has hydraulics. Example, the hydrofluoric acid, hydro, and fluoride. Replace IDE with IC, and it will become fluoric. And the name will be hydrofluoric acid. Next is, I ate something icky. Example is nitrate. Replace 8 by ick, and it will become nitric. The last line is, Sprite is delicious. Another example is nitrite. Replace it with OUS, and it will become nitrous. All we need to do is to remember this pattern, and we can rename acid easily.